how can you tell if a table is proportional or not? Well, it gets back to this idea of that constant ratio, right? You have to have this constant ratio or relationship between x and y. And very specifically, when you divide those two, you should be getting the same value each time. So let's take a look at a few of these problems. So looking at these, notice that it says dividing y by x. In almost every table that you see, at least in this format, you have you have the x on top. So you can very quickly do a rewrite to where what I'm doing, I'm just putting the y values on top. Right, I just took these and moved them up there. And look, is -6 over 3, is that equal to -4 over -2? Yeah, it is. And the 0 is kind of questionable, but this qualifies, right? That is the ordered pair 0, 0. So that's okay. Then we have, 2 over 1? And then we have, 4 over 2? All of those are equal to each other. So that's what I mean. You check by dividing the y and the x to see if you get the same value each time. And in this first one, we do get the same value each time. So this is definitely a proportional relationship. Do the same. Oh, I don't have the 0, 0. A lot of times people think as soon as they see a 0, 0 that it's good. And a lot of times they're true, but you should still check, and I'll show you why in a moment. But for right now, I'm just checking the proportions. Right? You got, if you write this, you have 3 over 1, which is equal to 3. 9 divided by 3 is 3. 21 divided by 7 is 3. Right? So I'm kind of showing you 30 divided by 10 is 3. 42 divided by 14, 3. So this qualifies. Right? Even with the negatives, remember, we're dividing the y divided by the x, y over x. So looking at that, -12 divided by 4, well, that's 3. Oh, look, wait, is it 3? -9 divided by 3 is 3. 3 divided by 1 is 3. So again, this one qualifies as well. That's how you check to see if a table is proportional or not. So let's look at some examples where things are not proportional. Non-proportional tables. Tables that do not have a constant ratio. That is, when you divide by the y and the x, you get different values. Okay? So looking at our next little piece here, this little group, let's start dividing. What is 9 divided by -3? 9 divided by -3 would be -3. 4 divided by -2 is a -2. Right away, this is not equal, right? If you get different values, then you're dealing with a non-proportional table. Oh my goodness, this has a 0, 0 in it. Be warned, just because you have the coordinate just because you have the coordinate 0, 0 does not imply immediately that it's proportional. There are non-proportional tables that have 0, 0 in them. It's just this part where you have to check. You have to check to see whether or not this works out for you when you're dividing the y by the x. Going through here, -1 divided by -1 is 1. 3 divided by 1 is 3. Fail. -5 divided by 4 is, 5/4. 0 divided by 1 is 0. Fail. So that doesn't work either. So that's how you're going to be able to tell the difference with tables.